Welcome. We're looking at Africa right now. So, someone posted on Reddit about just this general region, just asking about it. And of course, I started to provide my reply of what I could like quickly gather. And here I am now pointing out the things that I was pointing out in that response. Now in like video format, at least kind of using that as a template or beginning topics to talk about what I'm going to talk about. So it's just this region here, which I pulled up the topographical map in the region, and so it's here. It's got some kind of general, like it's part of a boundary of this maybe this is triangular. Corner, 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 like a triangle here that's adjacent to this triangle. So in this triangle, the topographical map is really exciting because it shows a central region here that then has like a protruding topographical elevated region in 3 directions, maybe even at interesting angles. I can't do them. I guess if I point it at from maybe here, that's probably about center to there. And it's around 120 degrees. So it's pretty well like 120-degree corners that all meet here. And so if we look like over here, here's this circle, and then here's that corner. So maybe this corner is like part of specifically this system here. So here's that circle we were just looking at. Here's that triangle. And then it's got a corner. I was thinking it goes really down through the entirety of it, though. Like, it really does. It goes over here, down this way, across this way, up this way at an angle, kind of like the Mariana Trench, like a current's pushing in across a boundary and just, like, pushing it in an arced way. And then more straight across here, making a pentagon shape here. So we got a pentagon with a triangular corner. And then add the node of the pentagon over here. There's another center here that has a secondary center off of it. So if we look at this center, then we see again like a top edge. We're here, one or the other, really, or both. And then maybe across here down. I'm not sure where I drew this. Maybe just like this to here. I think I drew it, so let's just look at my drawings now. Here are the regions I drew. Here's that one I was just talking about with the Arctic region here. Here's the triangle down here as a corner. And then up there, sorry, like trying to clean my mouth out. Disgust. Dude, you're disgusting. Could you like not hit record 2 seconds after eating? So I noticed these features. I think it's a current going in this way and then spreading out here, and generally through a polygonal boundary that the overall currents are inducing. The one current goes through this way, I think, coming from the mantle puncture hole direction over there, over to maybe interact even with between North and South America. Let's see, like across this way, two around here, which really would have been like basically here. It's possible that the Western Pacific this region that opens up this way, which I've basically been putting here. It's possible, and saying that this current then fanned out like this. It's possible actually that maybe this current went down this way more so, and then another like secondary current that was coming generally. I was thinking like this, down this way, actually not quite from the mantle punctural, but from here across this way, literally leapfrogging boundaries, going across them, flowing, like a lot of it redirected this way, the lower elevation, like the water depth or whatever, the depth, not water depth, the flow depth of what was flowing, like some of it would run into the resistance, but some of it would physically flow atop it, and I believe it just flowed over to this boundary here and basically made this boundary and went across here, but then across here, maybe it also went down through here. There's currents coming in this way, across this way, but then there's currents coming across this way, so there's a lot of cross-current interactions going on here that lead to a lot of like straight line type things at different angles, which makes this whole region just very, very unique in terms of just the way it looks. Like nothing else has quite as distinct of these like circles with polygons, Like it's kind of over here in places, like here, but it's not as visible what's going on like up here, over that way, and then maybe down that way. It's just not as distinct, or like maybe over this way, all this whole thing, but like it still doesn't have a distinct center point. Wherever here, they really show that is a thing that happens, especially in probably more intense circumstances that were present here due to the proximity of what's going on over here. So there's another one, and then there's this one, which has the Eye of the Sahara generally around its general boundary. I mean, this one is more subtle. This one, I start off of this, which is that current going across. So in this one, notice, current goes across, creates this region. That's hypothetically, is why this kind of protrudes into the polygon and into the polygon across the center, and like it could go east, but I'm thinking it goes west, and then like goes through a narrow point of the center, and then fans out past the resistance, and then creates a boundary that then behaves literally, or the upper boundary, like that whole thing being within it, pushes out an upper boundary of another polygon. That then at the upper boundary is the boundary, I just noticed this. Upper boundary is the boundary, lower boundary of this stream going across. Lower boundary actually goes right to the Eye of the Sahara. It's very common for, like, at the boundary, like if we look at where currents are interacting in the Pacific, there's a current going this way and this way. So it goes this way, like this whole width, all these straight lines right to here, to the boundary of where it generally goes is this region, and then there's another current interacting with it from over this way, which physically is cross currents, and that's just like happening all over the place, like cross currents up here, causing these nova centers, these circular like things going on. So there's probably the eye of the Sahara is probably closely tied to that. There's currents coming from South America into Africa, but then there's currents coming from over here into the northern Africa. So at their like where they're interacting was maybe along this path, like right through here, like right through there. And then that even goes to Cape Verde. Whereas over here, what is this again? The Canary Islands. It's all at this boundary extending outward. Definitely a relationship. And then it's kind of suggests a vibration where like this one goes straight, so maybe there's another going more straight this way that like across, I don't know. Or it just split after here. It like by passing through here, it caused like a divide in the energy. Maybe like the positive energy flowed more over here, which caused more density, and then over here it caused like a pocket of voidness that bubbled. I feel like it's something to do with some kind of bubbling mechanic that's not quite the same as other things we're used to seeing that makes it so anomalous. The Eye of the Sahara, in terms of how it formed. But it's certainly at one of the like critical nodes of the corners, which points to its relationship to this network of polygons that even extends over here and looks like it may be split in half. This like a polygon extended over here, maybe. I don't know. It's hard to say because it's not as visible. Here looks like another center. Definitely another center down here, but these are caused by the current coming down this way, and again the current coming from South America across, which we can see it literally cuts across here especially, which then goes over to there, right where this comes in, and then just goes straight above it and straight, so it comes in through that region, passes it, and then crosses streams, which then causes vibrations, leading to a void here, void along this way, void along this way, but like density probably. Maybe some density over here relative to this, or maybe it's more like separated, like dense void, like it pushed material over here within this zone. Something of that nature, where something of that nature is also going on up here with cross currents, but it's just different. Like it's pretty much there's a current coming from over here, generally speaking, from the mantle puncture hole, from up here as well. Like all these currents that generally want to go westward by the rotation of the earth, literally, they are like being trended that way. And so they flow that way, but then there's another current that's like being forced in opposition the other way, going in opposition because of the back pressure of the like leading wall of this like moving westward current that then just builds and builds until it just can't move as well, and it just sits there. And then the new outflowing current has a literal wall that then causes it to go against the rotation of the earth, so then it starts going eastward this way, more so in a way where then like a jet is flowing under South America, making a literal flame shape Like, it looks like a flame because it was a flame flowing like a flame from the base to the top, flowing this way across into here, and like de decaying the nucleus of the crust is my interpretation, that this was like the heart, the biggest nucleus of the crust that literally got decayed in the process. Possibly formed also in the process, but then got decayed. So there's that going on with, maybe that's good. There's probably more polygons we can look around like here. Let me get rid of that one. Let's go back to, I downloaded Google Earth Pro. It would be nice had I been using this all along, but at some point, let's see, there's probably polygons in North America we can look at. Like down here in this region. That's just similar structures. If I could make this. I don't want to get just sitting here looking around, but that's basically what I was thinking about Africa. I guess I'll just stop here and make another video because I want to talk about a paper that I read. Or fuck it, I'll just do it's just totally different topic. I didn't actually read the paper. I looked at the paper. I mean, to a degree, I read the paper. I didn't read every word of the paper. You get that? You get the point. Okay. An alternative. This is a article from 2007 called "An Alternative Gondwana." Biota links South America, New Zealand, and Australia. So yesterday, I had this thought. Why don't I Google, literally, I go to some Google Scholar. This is how I like blanket search for things. Is there anyone talking about these types of things? Literally this. I did this search. Tasmania, South America, geology. Anyone who's mentioning these two, let me see what they say. And I immediately found this paper, which is quite incredible because it is not, as far as I can tell, it does reference expand. So if I type expand, it's talking about the opening of an ocean. It's not talking about the expansion of the earth, but it does reference it. Carrie, these two are the original proposer, for as far as I could glean. I don't really know that much about expanding Earth history in terms of like theory and proposals around it. I don't think that they're like that important for me because I literally found my own evidence, and like basically coming across this type of evidence is just gonna add clarity. Be like, okay, more evidence, and let me bring it in and clean it up a bit. All these attacks on it that are unsound, but like the detail couldn't by itself, without some other details, be defended. Anyway, this paper doesn't, in my recollect, like reading and just searching expansion, like they're not actually proposing expansion. So and then if we go to carry, so what I found really interesting is they reference a paper by someone who's talking about the expanding earth and don't actually like explicitly bring that into the conversation, although at that point you almost have to mention it because like it's almost like we're denying the expanding earth, but we're going to use the map. So basically, this map here is from Carey's work. And so, what this paper is arguing is that because we historically have viewed the map like this, with basically this being center line and the Pacific divided, it leads to a unintentional Atlantic based interpretation, and that leads to the Gondwana assembly as we see it today. So look at this. Notice this. Australia, Antarctica, Papua New Guinea, generally where I put them. Gondwana. Where does Gondwana put them? Gondwana puts them over here. So they're not over here, they're over here in our current interpretation of Gondwana. According to our current interpretation, Australia and Antarctica are not adjacent to South America over here, because there's evidence that they were connected here. And I agree, there's evidence they were connected there. But what's not being acknowledged, and is really interesting about this paper, is that there's evidence that they were connected over here too. But this paper is basically, instead of bringing the this is why it's so like mind-boggling that they're using a map based on an expanding Earth paper without mentioning the model, even though they have evidence that basically shows the Earth expanded because it was connected here and it was connected here. It was just a smaller globe, so that over here connected over here. So it actually was connected. And both sides are true. That's the thing, is both connection points are valid in the debate that's going on here. So if we look down here at their, essentially all researchers who have provided wide-ranging biogeographical analysis of South America, Australia, New Zealand have concluded that many of the biotic links among the regions are indicative of vicariance. I'm not even sure what that means, but let's check it out. Not vicarious. What was it again? Vicariance. Geographical separation of a population. Pair of closely related species. So basically, a population that was then separated and caused to deviate but be still distinguishably similar, I guess. So there are relationships in that way. Posit long distance, even these San Martin and Ronquist, who posit long distance dispersal for the biogeographical pattern displayed by plants, agree that the animal links are best explained by vicariance. Apparently, the only disagreement involves the question of the vicariant event. That is, the researchers disagree about the geological cause that led to the disjunctions. Let's find what I was actually looking for. I thought that was it. Let's just go to geological facts. Here we go. Given all the difficulties generated by attempts to explain disjuncts, assuming the conventional reconstructions, one would assume that the geological characteristics of the seafloor between Australasia and South America overwhelmingly support this view, and that the current distributional explanations, like the cross-ocean rafting of Fijian iguanas, are hypotheses of last resort. Like, don't do it unless we really have exhausted all other options, but we've just concluded it immediately. Yet the South Pacific seafloor data confirm that essentially all of it is less than 83 million years old, and the vast majority of it is less than 40 million years old, mind you, according to radiometric dating, which is not actually valid, except for relative aging, not for absolute aging, until we correct for the assumptions and things that we've just not realized to be doing. This is consistent with the fact that Australia, New Zealand, and South America share so many more closely related extant taxa than Africa and Madagascar or Africa and South America, based on crustal age, so even more than Africa and South America. These are related. Wow. Based on crustal age of the seafloor, we know that Madagascar rifted 121, northern South America rifted about 100 million. This same reasoning based on crustal age data would imply South America and Australasia remained in proximity until a much later date. The biogeographical links predict the differences in ages of seafloor between the various Gondwanan regions, with the strong trans-Pacific links supporting the juvenile age of the South Pacific. Conventional paleomaps that indicate a significant separation of these trans-Pacific regions during the Mesozoic assume the existence of enormous ocean-wide tracts of hypothetical seafloor crust that have since been subducted. This is how plate tectonics works. Well, it must have been there, because we would be wrong otherwise. But all evidence for precisely how much of the seafloor actually existed has been forever lost at trenches. As noted earlier, Briggs and Metcalfe have now juxtaposed regions that were previously thought to have been separated by the Tethys. The reason their views are geologically viable is because the ancient Tethys has now been completely subducted. Regardless of what used to be conventionally drawn on paleo maps, no one really knows how large the marine gap was between any of the circum-Tethys regions. Okay, let's move on to something. The same reasoning applies to the Pacific. Not only has all pre-Pacific seafloor been subducted, the disjunct regions actually share many more closely related taxa than do any other disjunct regions now known to have been juxtaposed. So they're basically saying, yeah, these were next to each other, guys. What are you guys doing? Regions on opposite sides of the Pacific, particularly Australia and South America, fit together neatly. Reuniting the matching outlines closes the biotic disjunctions and brings together many trans-Pacific sister taxa. The trans-Pacific regions also share geological links. For example, geological correlations between Northeast Australia and Mexico and where did you say? I think they said Mexico. I'm not sure. I gotta read. I'm a little high. I forget fast. Yep, Mexico. Yep. That's right. Involving greenville-type Proterozoic basement material have led some geologists to juxtapose these trans-Pacific regions at that time. The resulting configuration is now known as Osmex. Interesting. We also find Proterozoic Greenvillian material in southern Peru. down here. Down there. Southern Peru, showing a correlation between these regions in eastern Australia. Also now, not only did the Caribbean and Ontong Java plateaus just north of New Guinea form at the same time, the Caribbean and Ontong Java plateaus, so like the Caribbean, like this region, and a mound of like crap down like this. I think it's this region. There's just like a bunch of material in a big mound, which actually kind of is adjacent, so that would probably be the one. It's probably this one, just based on the trail. Like we could follow the trail, this trail, follow it over to right around here. So it probably is closely related to the Caribbean just by its proximity. As a backstop in some way that was like encouraging flow this way. Looks like it, like, and it was off of here, and this, like, there was definitely pressure flowing, the current flowing underneath here, pushing out this boundary that was down here, pushing it out, and then leading to this boundary, I guess. Maybe leading to this too. Like it came up this way and it split, went this way or this way. Like through the nose of this bird head. And out the tip. Blah blah blah, y'all. Just northeast of New York, with eruption peaks at 120 million and again at 90. They also are remarkably similar in chemical and isotopic composition. Reconstructions that juxtapose Australia and New Zealand with South America predict that we should find matching trans-Pacific outlines, geological correlations, and a great number of disjunct sister taxa. In contrast, those working from conventional paleo maps often express some measure of surprise. What do you mean there's a connection across the Pacific? At the trans-Pacific relationships, for example, Anderson noted that his molecular DNA analyses of liliginid squid, which lack teleplanic larvae, suggest something, a species found on the other side of the planet from blah blah blah, are suggest this Indonesian and Caribbean squids are sister species found on the other side of the planet because the Pacific opened. About the occurrence of iguanas on Fiji, Tonga, wrote that long-distance dispersal from the Americas, incredible as that seems, is the only viable hypothesis that explains their presence in the Southwest Pacific. In a discussion of multiple trans-Pacific disjunctions among Abrotinella, wrote that possible long-distance dispersal events of Abrotinella are hard to envision, however. Phrases like incredible as that seems, hard to envision, and on the other side of the planet help underscore that extraordinariness of these distributions and seem to imply that the researchers understand that their own biogeographical hypotheses may seem improbable. These improbabilities, well, they understand that it's surprising to them. I don't think they're understanding that it's the biogeographical hypotheses that's improbable. These improbabilities continue to multiply with every disjunction, and as noted, the regions share hundreds of identical or closely related taxa. Those who place the southern Pacific continental regions in proximity in the Mesozoic are doing nothing more than letting the biogeographical facts speak for themselves. They are letting the data determine their conclusions regardless of challenges to convention. The situation is reminiscent of a legendary story of the Dirac equation in physics involving Paul Dirac and the development of the Dirac equation, an equation that requires the existence of a particle very much like the electron, but that is opposite in sign. This consequence of the Dirac equation was famously confirmed in 1932 by the discovery of the positron, but Dirac himself had never formally predicted its existence. When later asked why he did not underscore this unconventional but natural consequence of his equation and boldly and formally predict the existence of the positron, Dirac responded flatly, "Pure cowardice." Because of the fucking waves. You wrong, bro. You wrong, bro. You don't say some shit I disagree with. Huh? No, he didn't. This motherfucker wrong as fuck.